Hiya, can everyone hear me? Hello, hello. I am going live now. This is super exciting. Can everyone hear me? All right. I think we are ready to start. Hi, everyone. This is Natasha from Nextwork here.
Hiya, can
And this
everyone
is
hear me?
time for another live. This is so exciting. We are now at part 3 of our networking series. And honestly, parts 1 and 2 have been a lot of hype. It's been a lot of fun seeing everyone's documentation on setting up your very first VPC, setting up your very first subnet, your very first route table. And I think part 3 is such a good milestone for us to review what we've done so far and also add a little extension to it by creating a private subnet. Now, this is going to be a lot of fun because private subnets are quite different to public subnets, which is what we've created with our VPC so far. So yeah, it's going to be quite fun. We're going to create a private subnet. We're going to compare that to the public subnet that we've created in the past. And hopefully we'll get to take away a few more learnings with how VPCs work from this project. Now, at the end of the day, the projects are all about learning. So a lot of this live demo today is just going to be us recapping some of the concepts, just talking about what do these features in a VPC really mean, and overall, just have a good time. Thank you so much for being here. A big shout out to everyone in the chat. Oh my goodness, I don't think I've seen such an active chat before. Denzel is the very first person to join our chat today. Hello, good afternoon, Denzel here. It's always fun to see you. Stevenson says hello. We have Nicolay saying hi as well. Smed, Teslim. Oh my goodness, Nurfajrina says hello from Indonesia. Wow. Ida says hi from Kenya. Shantnu says hi from India. Oh my gosh, Dari says hi, Nat. I remember Dari's from Kuala Lumpur, so good to see you. Oladopo says, yes, I can. Oh, thanks. Fubara says, Fubara says you can hear me too. I'm very, very glad to hear it. Abhishek says, hello, Natasha. Hi, Abhishek. Wow, this is so fun, everyone. Vamsi says hello. Etelvino says yes. Oladapo says hi. Ivan says hi. Oh my gosh. Wow. Hi, everyone. The Nextwork community is thriving, isn't it? Oh, this is so cool. I love doing projects with everyone. And today we're going to find our project by heading into the All AWS Projects channel in the Nextwork community. If you haven't joined the Nextwork community yet, you can find the link to that in the description box. And once you're here in this channel, scroll down and you're going to see the project for today called Creating a Private Subnet right here, Project 14. So let's click on that. And you can start your project right here in the very top link. Super convenient, isn't it? So once you click on that link here, you'll get taken to what you see on the right-hand side of my screen. This is the step-by-step guide for today. And once you have that ready, I would highly recommend that you log into your AWS account, ideally as your IAM user. And if you don't have an IAM user yet, that's okay. You can still do this project using your usual AWS account's root user. But the IAM user is honestly such a great option for security reasons. And if you haven't created an IAM user before, we have a link to that in the description box as well to create your very first IAM user. It takes about 10 minutes. It's a really good practice to have. In the meantime, wow, we also have Supriyo saying hello. Akanksha saying hi from New Zealand. Wow, same here from New Zealand too. We have Hodono. Hodono says hello from Benin. Wow. King of Zamunda, what a name, also says hi. All right, let's get started. So, with our project step-by-step guide, as always, it starts with a 30-second summary. Welcome to your third AWS networking project. We're already in the third one. That's wild to me. That's wild to me. In your first 2 networking projects, you've already created an Amazon VPC, amazing, a public subnet, woohoo, an internet gateway, go you for creating that, a route table, that was really good, a security group, say what? Yeah, you created a security group, and a network ACL, also called a network access control list. Super cool. Fun fact, super cool is Amber, our CEO's favorite phrase ever. So if you hear us say super cool, we probably learned that from her. So this is the architecture diagram that summarizes what you've created from parts 1 and 2 of this networking project series. And if you haven't done the first two parts, just know you can absolutely still do this project, can absolutely still follow along. It's just that having done the first two projects will give you a better understanding of what's going on, because this third project starts by repeating everything we've done in steps projects 1 and 2 of the series. So you can definitely still follow along when we repeat them. It's just that if the steps are a bit confusing, or you're like, oh, I would prefer a slower explanation of things, I would highly recommend that you visit parts 1 and parts 2 of the project so you can get that explanation. So with that being said, today we're going to level up by creating a private subnet in the VPC. So you'll learn all about private subnets in a minute. It's entirely what this project is about. But in summary, we're going to get ready to 1, create a private subnet, 2, create a private route table, that's number 2 over here, hope you can see that, and 3, create a private network ACL over here. So this is going to be very, very, very interesting, trying to compare the new things that we're going to create over here, this section, with what we've created already in that bottom row here. So there are differences between a public and a private subnet, and understanding the differences is going to be really important. Why is that? It's because a lot of applications in the real world need that separation between public and private subnets. So when we started creating our VPC and our public subnet in the first two projects, we talked about how the public subnet can have access to the internet, and it's accessible by the internet too. So that means anyone on the public internet can literally access the resources in your public subnet through the internet. So that's a really, really great thing for accessibility. And it's the reason why web apps, like if you go to nextweek.org, if you go to netflix.com, if you go to Facebook, if you go to Instagram, if you go to TikTok, how is it that you can access this web app? It's because that web app has been hosted in a public subnet. But why is it that I can see the web app, I can see, all of the content, it is really, really cool, but how is it that TikTok's user base, how is it that, for example, Nix works like confidential data, how is it that for a bank or for any financial institution, their customers like bank account data isn't so accessible, isn't so private, isn't so public? It's because private subnets exist. And the whole reason why people can keep such confidential data to themselves and really secure and protect them from anyone trying to get access to them is because of private subnets. So you can think of your public subnet as a great subnet or a great subsection of your VPC to have for anything that you want to be very public facing, that you want people to see. But if you want to keep things confidential, that absolutely people on the internet shouldn't be able to just like find randomly when they're surfing on the internet, you're going to want your private subnet to come in place. So you can really think of a public and a private subnet that as two things that really go hand in hand. We've created the public subnet in the very first two parts of the series with that bottom row, and now let's pay our dues and create the private subnet as well. So yeah, I hope that was a good intro. And with that being said, let us get started with step 0, getting ready to document. Documentation is, wow, a lot of people I swear in this community have a love-hate relationship with documentation, by the way. It always makes us laugh when we see all of you post your documentation and there's 1 or 2 lines about how like, man, documentation is hard, or, oof, I'm not a fan of writing documentation, because we totally relate to that. And the whole reason why documentation exists is for 2 reasons. 1 is for you to reflect on what you're doing. So sometimes when you're doing step-by-step projects, it's so easy to be like, click, 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 done, 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 type, 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 without really getting to reflect on like, wait, what am I really doing? Or why am I doing this in the first place? So documentation helps you with doing that reflection. And the second thing is it is so good for having a piece of evidence for all of your hard work. In a world where AWS is going to start charging you for leaving resources in your account, you're going to want to delete all of your resources. And that's what we're going to be doing at the end of this project. But the other important thing is, once you've deleted your project, how are you going to show to employers, how are you going to have evidence in your portfolio that you have done this project? So this documentation is absolutely that key piece to that puzzle. It is the thing that's going to live on even after you delete your resources. So you can always come back to this, point at your documentation and be like, yeah, I did that. And these are all of the learnings. You're welcome. So let us get started and head on to step one. And yeah, if you're wanting to write your own documentation, click on this link here, this blue link that says creating a private subnet. And then we can also find the documentation template right here once you click on the link. So you won't be able to edit the template directly. This template is for everyone to share. So if you ever want to write in this template, make it your own, you can. How you do that is by finding File on the top right-hand corner of the page, click on File, and click on Make a Copy. So once you click on Make a Copy, this new version of the template, is yours. So now you can go crazy, do everything you want with this, take complete creative control because this copy is yours, and you can, just close the tab with the template itself. And in here, just start by replacing that title. It says copy of. We don't really need that part of the title. We can change copy of to Net's, because Net is my name. Or you can put like Denzel, Abhishek's, Fubara's documentation template, and do the same for the your name section here. So I'm going to change that to Natasha Ong to make sure, to kind of remind myself, okay, this is my documentation template. Alrighty, so when we're ready, let's get started with step one. I'm such a talkative person, I feel, whenever I'm doing these Project Live demos. Like I'm like, wow, like I feel like it's been 10 minutes already, and finally we're starting step one. So thank you so much for always sticking around and and enjoying, every single part of these live project demos. And in step one, we're gonna set up the VPC's basics. So step one is always just a repeat of what we've done in the first two parts of the project. And let's challenge ourselves and see just how much of the first two parts we can really retain and do without a lot of guidance. And yes, shout out to everyone in the chat, by the way. This really has been a pop-in session. We have Wesley saying hello from Kenya. Hi, Wesley. And we have Stefan saying hi from Moldova. My goodness, that's awesome. Arun says hello from India. Denzel says it's hard to reflect on the spot. No, you're not. I don't think you're joking about that, are you? Michael says, hello group. Hi, Michael. Steven says, hi, Natasha from Houston, Texas. Wow, I wonder what time it is over there in Houston, Steven. Okay, so because we're repeating the steps from the first two networking projects, we're going to be doing the VPC, the subnet, the internet gateway, the route table, the security group, and the network ACLs all over again. And you can see the entire relationship between all of these elements in this diagram here. So again, what that list was saying, the VPC, that pink area, the subnet, the blue area, and we also have, my goodness, I'm almost losing track, internet gateway right over here in that yellow area. And then we have the route table over here, the security group, that orange thing over here, and then the network ACLs in the middle here. So we are kind of dancing around this architecture diagram throughout this project, but it's okay if you're a bit like, I kind of forgot what this does, because we're going to recap all of that as we go. First things first, create a VPC. The VPC is the foundation of this project, so let us head to AWS Management Console, and let's zoom into that search bar at the top and type in VPC in there so we can find the Amazon VPC service in your AWS account. And when we're here, we have this big ass dashboard that kind of represents here are all the VPCs across your regions. But really what we're wanting to see is your VPCs on that left-hand side. Click on your VPCs and let's create a new one. Okay, so when you're here creating a new VPC, we're going to name our VPC Network VPC. Boom, like this. And we're going to give it an IPv4 CIDR block. So quick recap of what we're doing so far. A VPC is your corner of the entire AWS region. So in my example, I'm in Oregon, the Oregon region. Make sure you're picking a region that's closest to you, by the way. So I'm in the Oregon region, and when I'm creating a VPC, I'm creating this isolated portion of the Oregon region that contains all of my AWS resources that I launch in that VPC. So you can think about the Oregon region as this like huge bucket of all of the different resources that get launched into the Oregon region. Imagine just how many resources are being created inside your region. You know, you probably create like 5 in a project. Someone else in the same region creates like 10 in there when they're creating a project. So many resources are out there and they're all created in the same big region. So how is it that you can't access someone else's resource and they can't go in and just like start uploading things in your bucket without your permission? It's because VPCs exist, and VPCs are kind of like boundaries that surround all of the resources that you launch in there to kind of protect it and make sure it is your own corner, you know, of this entire region. And the reason why VPCs like are so important in this entire like universe of AWS and AWS services is because VPCs are how you start to connect all of your services together. VPCs are also how you make your resources available to the internet, or how you start to grab data from the internet to add features to your own resources, for example. So many things branch out from having your own VPC. And that's why we are going to be creating a VPC again and again and again throughout this series, so you really get those foundations straight. And yeah, now that we're here setting up the IPv4 CIDR, the IPv4 CIDR is basically the set of addresses, or the set of like street names and postcodes that's going to be allocated to your VPC. So you can think about how like when you are in a huge country and the country is like your region, your VPC is like your own city, and then the IPv4 CIDR is like the set of addresses within your city. This IPv4 CIDR ends up having a huge impact throughout your entire VPC and later on, because whenever you're creating a resource, you're kind of like allocating one address from your entire CIDR to that resource. You kind of like say, hi, when you're creating a resource, you're kind of like building a new building in your city, and you're saying like, this building has this specific street name and this specific postcode. You're like allocating it one address into your entire city. And that IPv4 CIDR block is like a whole block of addresses you can give out. So it ends up determining a lot of different things, later on in your project. That's cool. So now that we've set up your IPv4 CIDR block, we're going to scroll down and select Create VPC. Awesome. So we have created our VPC now. You can imagine it as like your city is now born. So you have this big city that's now available for you to play around with. And what we're going to do first things first is to create a subnet. So we've created our VPC, we've created a huge city. And if you think about it, what is kind of like the next level down? We have country, we have city. What's the next level down? So subnets are kind of like neighborhoods or suburbs within the city, and we're going to create a subnet right away. Now, you might notice this project is called creating a private subnet, but that's not the first subnet we're going to create. The first subnet we're creating is a public subnet. So how that's going to work is you're going to click on subnets on that left-hand navigation panel, and we're going to click on create subnet on the top right-hand corner. So let's click on create subnet. And here we are. We are at this page now where you can customize your own subnet. So the first thing you're going to see when you're creating your own subnet is like, okay, which city is your subnet going to belong to? So which city is your neighborhood going to live in? We've just created a new city called Network VPC. So that's the VPC that the subnet is going to belong to. And now let's configure our subnet. The name is going to be called public1. And we're going to put it into our subnet name. We have an availability zone. So the availability zone, we can just select the first availability zone in the list. So in my case, it's US West Oregon. It is US West 2A. But I would imagine it to be something A for yourself when you pick this for your own region. And next thing is the IPv4 VPC CIDR block. Goodness me, I feel like sometimes when you're learning AWS, you almost get lost in all of these names that when you read it, you're like, wow, there's so much little bits of jargon just in that title alone. So if we were to break that up, this is basically saying this is a set of addresses that belongs in the entire city in total. So Remember how when we created the VPC, literally in the previous step, what we did was we determined the block of addresses or the set of addresses that belongs in that city. This is basically AWS just reminding you like, oh, by the way, these are the set of addresses that you're allowed to give out in your city. So please, when you're determining what set of addresses your subnet can have, what set of addresses your neighborhood can have, please make sure that subnet's set of addresses falls underneath that VPC set of addresses. You can't suddenly give away addresses that don't even belong in that country. So AWS is pretty much just reminding us, oh, by the way, like these are the set of addresses that you can even give out. Please make sure when you're determining your subnet's CIDR block that it falls within this range. So what is within this range? For us, we're going to select 10.0.0.0/24. So we're going to put that into our subnet CIDR block. And what that means for us is out of this entire big range of addresses, by the way, like 10.0.0.0/16 basically means that this entire range of addresses, the second to 0.0, can be anywhere between 0 to 255 and anywhere between 0.0 to 255 there. So if I were to illustrate that basically means, okay, I'm going to borrow this text field as a little writing space for me. So when I have 10.0.0.0/16, that basically means addresses can go anywhere from 10.0.0.0 all the way to 10.0.255.255. So the range of addresses is huge, right? Because you can have addresses that goes from 10.0.5.1, like that's like one address, and then you can also have another address that's like 10.0.63. I'm having fun with this. 167. Like, do you see how the range of numbers can just go everywhere in this entire big range of addresses that can belong to your VPC? So there's so many different addresses that you can play with, and with our subnet, we're pretty much just allocating a chunk of those addresses that belong to your VPC to that neighborhood, and we're just gonna say we're gonna give it 10.0.0.0/24. So when it's 24, we're basically saying that the first 3 sets of digits in our CIDR block is going to stay consistent, but then that last number can go crazy. You can give it any kind of number that you want between 0 to 255. So that's going to be a range of 256 addresses that can go into your subnet CIDR block. So cool. Now that that's all done, we are going to create our subnet. And boom, our subnet's created. So that's awesome. And we are going to make sure that our subnet is public. So there are 2 things that we need to do to make sure our subnet is public. Actually, it's a bit more than 2 things that I'm thinking about it. There are a few things that can make our subnet public. We're going to go through all of those steps in a minute. I would say it's about 3 steps instead of 2. But one thing that we can definitely do to customize the subnet is enable auto-assign public IPv4 address. So we're going to click on Actions, and we're going to click on Edit Subnet Settings, and then we're going to scroll down and tick Enable Auto-Assign Public IPv4 Address. Does anyone remember what this does? I feel like this is quite like a niche, small little setting that goes a really, really long way, and you're going to see the impact of that in one of the next few projects. Not yet, but one of the next few projects. But if anyone in the chat can remind us what that setting does, gold star to you, my friend. Gold star to you. In the meantime, let's have a chat. Let's have a look at the chat. Wow, this is so cool. Brenda says hi from Kenya. Abdullah says hello from Malaysia. Linda says, good to see you, Wesley and Ida from Kenya. Woo, Kenya's popping off. Salam says hi from India. And, oh, Denzel says, love the analogy. Abdul says, hello, Natasha. Good to see you. Good to be here again. Abdul, it's always so fun to have you here. Linda says Brenda too from Kenya. And we also have VS Pat Lola says hi from India. Wow. I need crash course on AWS and GCP with 5 mini projects. Wow, this is really cool. GCP's on the way in the future. AWS is our focus for now, so we're going to keep on going with AWS. And you can find the entire suite of projects in the All AWS projects channel in our community. Link in our description if you're not part of that community yet. Kinde says, hello from Ohio. King of Zamunda, first one to mention in the chat, it automatically assigns your IP. Yeah, pretty good, pretty good. Karen says IPv4 makes your subnet accessible from the internet. Yeah, it really does. Like having a public IPv4 address for a resource makes it accessible from the internet. And when we say enable auto assign public IPv4 address, we're saying that now that this setting is ticked, by default, whenever I launch a resource in my public one subnet, that resource is automatically going to have a public IPv4 address. Because if we left that box unticked, what that means is when I launch a resource in that public one subnet, they're actually not going to be accessible from the internet yet, because they need a public IPv4 address to be accessible. But if I just tick enable auto assign, it means that they automatically will get that public IPv4 address. They automatically will become accessible from the internet. So that was really cool. With that done, I think let's move on to creating the internet gateway. So the internet gateway is what's going to connect our VPC to the internet. So let's create that right away. And I'm going to speed up a little bit now since all of these steps we've done before together. And we're going to create the internet gateway and call it Network IG. Like this, and then we're going to attach that gateway straight away to our VPC. So we're going to attach that to Network VPC, and then click Attach Internet Gateway here. Perfect, that was done. So now that that Internet Gateway is attached to the VPC, what does that mean? What does that do? So as a recap, internet gateways are pretty much what connects your VPC to the internet itself. So once you have an internet gateway attached to your VPC, it means now that there's some sort of way for resources in your VPC to get access to the internet. So now people from the internet can somehow get access to the resources in your VPC, and the other way around as well. If resources in your VPC, like your EC2 instance, ever needs to access data that's being held in the public internet, they can go out and do that. But the problem is there's no route table yet. So now we're going to create a route table that connects our internet gateway with the resources in our subnets. Because imagine if the internet gateway is kind of like this dock or this pier that's kind of sitting at the edge of your city. You know, you've built this cool city, you have your neighborhoods, you have an internet gateway, and let's say the internet gateway is like this ship or this plane that's gonna leave your city and enter into the world of the internet. So this dock or pier, this plane exists, right? Okay, I'm gonna stick with the plane analogy. I think I like planes the most. But what if all of the resources in your subnet and all of the traffic don't really know how to navigate their way around between your subnet and your internet gateway? It's kind of like if you just plopped all of your people, like your citizens in your city and their buildings, and you just plopped it in the city, and you're just like, hey everyone, by the way, there's a plane that can get you out of the city and into the internet. You just say that and you're like, bye, you go. And then they're like, great, we have a plane somewhere in the city that can take me outside of the city and into the world of the internet. But where is that plane? They don't know. They don't know how to get to the internet gateway. And that's why VPCs really is like city design. You're now going to need a route table that kind of acts like a GPS or acts like the traffic controller that's like, you said you wanted to go to the plane, you want to go to the internet gateway, come with me, I'm going to show you how. Other way around as well. Now if someone, let's say, lands at the airport and they're like, wow, welcome, this is my first time at your city. How do I get to this specific resource that I'm trying to look for? Because this definitely happens all the time in the real world. If a user is trying to access a web app that you're hosting in a public subnet, they don't know the traffic that lands at your VPC, doesn't know how to get to your EC2 instance, doesn't know how to get to your web app, if there's no route table that kind of shows them the way. So the route table you can think of as a GPS, as kind of like the wayfinder for all of the traffic that's trying to get from one destination to another in your VPC. So with our route table, the other key thing about it is we absolutely need our route table to have a connection between your public subnet and give it a route to the internet gateway, to the plane, so that it can be considered a public subnet in the first place. So once you click on route tables on the left-hand side, the navigation panel, we're gonna we're actually going to have a look at the step-by-step guide first. And just notice that if you refresh the page, click on that refresh button here, you're gonna see that it goes from one route table to two. Always refresh your page because sometimes resources will look like they are not created yet or they're not deleted yet when they actually have. You just have to refresh the page to see it. And we're gonna view the route tables that are in our account, and you can see that there's a route table with 2 routes, and there's also a route table with a single route. The route table with a single route is the default route table that's been created for your VPC. So this is going to be the route that we're going to want to edit and make sure that there's a route to the internet gateway. So we're going to click on Edit Routes, and then we're going to add a new route and make the destination for that 0.0.0.0/0. And then we're going to give it a target, which is Internet Gateway, and select your Internet Gateway. So once that's done, we're going to click on Save Changes. That's done. Changes are all saved. I think one thing that we can absolutely do as well to make things very clear for us is to rename your route table so that you know this is the route table for your Network VPC. So we're just going to name it Network Route Table like this and click on Save. Awesome. So we have just created the route table, and this route table has a route that says if you want to get to the public internet, how you're going to get there is, go straight to the internet gateway. The internet gateway, or the plane that's going to leave the city, is how you're going to get to the internet. So that is what we've just set up with the Network route table. With that route being created now, now resources or subnets that are associated with this route table will know the way to get to the internet. So that's awesome. And let's click on subnet associations here. And you'll see we haven't actually associated this route table with your public subnet yet. So this is going to be quite important because we want our public subnet, which is currently without any explicit associations, we want our public subnet to be using this route table, right? We've just created this GPS, and we want our route table, we want our subnet to use this GPS. So we're going to click on Edit Subnet Associations, and then we're going to click on the checkbox next to Public 1, and then click Save Associations. Poof, done. So once we've associated our public subnet with this route table, we've essentially just said that this public route table with these routes is going to be the GPS that all of the resources in our public subnet. This is the GPS that all of the resources in our public subnet will use to find their way around our VPC, find their way around our city. So I'm going to quickly check in with the chat. I see we have a few new messages, which is awesome. King of Zamunda says, "Hey Natasha, quick question. If we never set up the internet gateway, would our resources still be accessible via the internet? And to flip the question, why will we have to create the internet gateway?" This is a very good question, King of Zamunda. So you might notice that without the internet gateway, there wouldn't be a plane, or there wouldn't be a ship that kind of leaves our city. So absolutely, we do need internet gateways in order for our resources to be accessible via the internet, and also for our resources to access the internet as well, going outwards. So I hope that makes sense. The reason why internet gateways need to be created in the first place, it isn't an absolute requirement for every single VPC, in the world, but internet gateways is absolutely important if you ever need a resource that's public. So if you ever need a resource that needs to be accessible to someone else, like accessible to a user, for example, then you're going to need that internet gateway. And I think another good thing to know is that internet gateways, because it is the way that you will get access to the internet, like your resources will get access to the internet, a lot of the time a VPC is going to have one, because a lot of resources probably don't just live in isolation by itself. A lot of resources actually need resources from the outside world. For example, if you're creating a web app, it probably has packages or dependencies that comes from the public internet, from the outside world, and it will need to be able to have a route to the internet in order to retrieve those packages and those dependencies. If you're unfamiliar with the term packages and dependencies, by the way, we have a whole project about that. It's called the Code Artifact Project in our DevOps series. So I hope that helps. Ask any other questions you might have about that, King of Zamunda, because it's a very good one. All right. So now that that's done, we are going to head on to the next thing. So with our route table done, the next thing is to think about security. So subnets is like, okay, we've created a neighborhood in our city, tick. Internet gateway, we've created a plane that can leave the city. So we have a way for resources to access the outside world. And we also have a way for the outside world, like the internet, to access the resources in our city. And then we've also just created a route table, which is kind of like the navigation of things. So now the resources in our city are able to find their way to the internet gateway if needed. But what about security? Because we haven't really talked about that yet, and that is going to be our next 2 steps. So creating a security group is the first thing we're going to do. And let us click on security group in that left-hand navigation panel. So we're going to click on security group, and we're going to click, have a look actually at the 2 security groups that are here on our screen already. And let us have a look at what's going on here. So I'm going to click on the checkbox next to a security group. I'm going to open it. And interesting, I'm just going to have a look at the inbound rules. You'll see that the inbound rule for a security group always says all traffic is allowed. And that is a classic security group rule. And then we also have outbound rules. Again, all traffic is allowed. Interesting. Next is this other security group here. Again, they have the exact same rules. All traffic is allowed. So if you're wondering why these default security groups exist, it's because AWS actually just creates security groups for you by default whenever you set up a new VPC. And that's because once this default security group is set up, any resource that don't have an explicit security group that you're assigning it will just be given this default security group. And having a default security group is absolutely a really good measure to have, because if your resources don't have security groups, it absolutely can't even receive any inbound traffic or give out any outbound traffic. So having a security group is just like an absolute necessity for any EC2 instance that you're deploying as well. And as a quick recap, if you're wondering what is inbound and what is outbound, inbound data is kind of like visitors trying to visit a website that you're hosting. Outbound data is like if your resources want to request data from the outside world, or if it wants to send out an email notification, that's also outbound data, because you're literally sending out email data out to people in the internet. So really, really good distinction to have. And we're going to create a security group here as well. So let's click on create security group in the top right hand corner. And over here at the top of the page, we're going to just say that we're going to create a new security group called Network Security Group over here. And the description is going to say a security group for the Network VPC. Let's put that into our security group's description. Cool. So once that's done, don't scroll away from this panel just yet. Let's click on that VPC field and check which VPC is this going to be created for. It's so sneaky, isn't it? Aha! If you just click on that, you're going to notice that by default, they're always going to assume you're creating your resources for the default VPC in your account. Is that the case? No. We're going to create this security group for our Network VPC. So just make sure you're always clicking the Network VPC here whenever there's a VPC field. And then when we're scrolling down, we're going to see inbound rules. So again, inbound rules is kind of like the traffic coming in, users trying to see your website, checking out your web app. And we're going to add a rule and just say type HTTP. Oh, scrolling down, HTTP. And the source type is going to be anywhere IPv4. Cool. So we have talked about this in detail, what these inbound rules mean in part 2 of this project series. So if you're wondering like, oh, what is going on here? I definitely recommend checking out the video for that part. All right, so let's create the security group, and it's all done. So we've created a new security group now, and this security group is ready to rock and roll. Again, it allows all inbound HTTP traffic, and it also allows out all kinds of traffic, not just HTTP traffic, to go out, to flow out from resources with this security group. So once that's done, we can now move on to your network ACL. So, okay, I'm gonna have a quick sip of water actually. So a quick recap about network ACLs. Network ACLs and security groups are both about your network security, VPC security, but what are their differences? Can anyone actually remember what the differences are? I would love to hear it. I would love to hear back from you what you think the difference between a security group and a network ACL is. In the meantime, I'm going to have a quick check of the chat as well. Wow, Uliana says, hi, Natasha. I'm doing my study presentation together with you. This is really cool, Uliana. All the best with your presentation. I'm so excited that you're here. This is cool. Awesome. King of Zamunda says security group will then be the airport. Interesting take. That's a hot take. We're going to debate about this very soon, King of Zamunda. VS Patlola says, hey, are you from New Zealand? Can I get AWS job openings from New Zealand? Ooh, good question. I have a few ideas on this actually, and how I need to stay connected with you. The best way to stay connected is actually through the Nextwork community. Absolutely, that is the first thing I check every day and the last thing I check every day as well. The best way to discuss things is to ask a question in the I Have a Question channel inside the community. If you're not a part of that community yet, I'd absolutely recommend checking it out. It's in the description box. And we have Plaxides. Wow, so good to see you again, Plaxides. This is awesome. Hey everyone, sorry I'm late. You're not at all late. We've all just been waiting for you. Not at all late. Really, really cool. I see no one's actually mentioned the differences between security group and ACLs yet, or maybe because of that classic delay between the chat and the live itself, but that's totally cool. Let's talk about that now. So you can see here in this diagram that you have security group over here, and then that orange box here. And then you also have network ACL that sits outside of your public subnet. See that difference? That difference actually means a lot in the world of VPC and VPC security. So let us talk about this. A security group sits inside your subnet. A network ACL sits outside of that subnet. So when you look at their differences, you can think about their difference in terms of the scope. That's the biggest difference between them, the scope of what they're protecting. A security group is at the resource level, which means every resource inside your subnet is going to have its own security group. Think about it this way. If your subnet is like your neighborhood, and every resource, like an EC2 instance, is kind of like a building in that neighborhood, a security group is at the resource level, means a security group is like a security guard that's standing outside of every single building. So just close your eyes and literally picture a street full of buildings, and outside of each building is a security guard, just like standing watch there. That is the level of a security group. It literally wraps outside, of our instance, because it's protecting our instance at an instance level. It's not going to protect one security group is not going to protect like 2 instances at a time. Although you can apply the same like template of security groups to multiple resources, at the end of the day, the security group is going to protect it at an instance level. And then we also have the network ACL that sits outside of your subnet, which means it actually protects at the subnet level. So if you have that picture in your mind of that street full of security guards standing outside every single building, now picture the community watchmen, like a band, like a group of people that's just walking around the boundaries of your suburb, around the boundaries of all of the streets, because it is protecting at a subnet level. It controls what kind of traffic can even enter the subnet in the first place or leave the subnet in the first place. And let's say a piece of like a data packet, a traffic, like sorry, I got tongue tied there. A bit of traffic can actually pass your network ACL. You know, your piece of traffic, and then you're trying to enter a subnet to get access to a resource. And then at the border of the subnet, there's the network ACL. There's the people that's like patrolling the border of the neighborhood, and it says like, "Hey, you! I see you're trying to get in. Can you tell me your protocol? Can you tell me where you're coming from? And I'm going to decide whether or not I can let you in." So you kind of give it its details. And let's say the border patrol or like your neighborhood watchmen are like, "Okay, fine, you pass. You can come into this neighborhood." You come into the neighborhood, but to actually get to a specific resource, you're trying to get into a specific building. So you're kind of like now traveling through this neighborhood, and you find the building you're trying to get into, and you're trying to get in. And then as you're about to get in, this like security guard just frigging like pops out, stands in front of the door of the building you're trying to get into. And it's like, "Yo, I'm the security group of like this resource, and I'm gonna need your details before I can let you get access to this resource." And you're like, "Whoa, okay." And you give it your details. You're like, "Hey, this is my source, this is my protocol, and then this is my source, this is my protocol. Can I be let in?" And then the security group is just that second layer of security. So the security guard's going to be like, "Okay, actually, yeah, your details are okay. You can come into and you can come into this building. You can get access to this resource." So that's why we would want both network ACLs and security groups when we're thinking about VPC security, because 2 layers of security always much better than one. So it's awesome to now be setting up the network ACL. Awesome to see everyone's responses in the chat, by the way. This is so fun. This is very, very fun. Shout out to Kehinde. Shout out to Denzel, King of Zamunda, Abdul. Wow. Solutions Architect. Hassan is here as well. Hi, Hassan. All of your responses are perfect. This is so cool. So now that we're going to talk about network ACLs, let's select network ACLs from the left-hand navigation panel. And let us create a network ACL. So the network ACL we're going to create is called Network ACL. Try saying that out loud, by the way. If you're in your room right now, if you can say things out loud, just try to say out loud, Network ACL. I get tongue-tied so often. If you can do it right in your first go, props to you. Again, let's make sure when you're selecting your VPC, select the Network VPC. And let's create it. Create your network ACL. I got tongue-tied again, didn't I? Shame on me. So once you've created your network ACL, select it. So select the checkbox that's next to the name. And we're going to have a look at the inbound rules and the outbound rules. So the inbound rules currently allows all traffic. Cool. And the outbound rules also allows all traffic out. So notice how it is just a asterisk as the rule number right now. As a recap, how network ACL rules work is your asterisk is kind of like the fallback option if all of the rules that you manually enter kind of don't pass up. Let's say when that community watchman is kind of like reviewing a piece of traffic and whether or not I can let them in, it's going to review all of the network ACL's rules in order of smallest number to largest. So you can always have outbound rules that starts with 100, for example. You can have outbound rule 100, 200, 300, 400, and then your community watchman is going to go through that list one by one. And then the asterisk rule is kind of like, well, if all of the rules above don't apply, then apply this rule at the bottom here, the asterisk. So it is okay that we just have one rule here, but it's always good to actually define our own rule first before our network ACL goes to any sort of fallback option, which is the asterisk. So we're going to do that first by creating an inbound rule. So let's select Edit Inbound Rules. And let us select Add New Rule here. And then we're going to select a rule number, which is 100. All right, so we selected 100, and the type is going to be all traffic. Perfect. So once that's done, our source, of course, is 0.0.0/0. And we're going to allow all of that traffic. Do you remember what this CIDR range or the CIDR block means? Have a chat in the chat. Have a chat in the chat box below in this video. And we'll see who can get it right. What does 0.0.0.0/0 actually mean as a source? Cool. Once that's done, click Save Changes. And that is your inbound rule all set up for your network ACL. So now let's do the same for the outbound rules. It's the exact same process. We're going to click on Edit Outbound Rules. We're going to add a new rule, rule number 100, and then the type is all traffic. So it goes down, click on Save Changes, done. That's your network ACL all set up. So that's awesome. And we have Joe in the chat saying, whoa, so many watching. Great to see. I know, right? It's amazing. Absolutely amazing. Hassan says, hi, Natasha. I'm late, trying to catch up. Oh, is that right, Hassan? No worries at all, mate. We've just been repeating the steps for projects 1 and 2 of the series. So if you've already done those 2 projects before, you're going to catch up in no time. Regardless, it's so good to see you here. Supriyo says, great explanation, thanks. Andre says, everything from outside VPC. Ooh, we have our first response in now for what does 0.0.0/0 mean. Hassan is following up quick by saying this CIDR block means everywhere or the internet. Ooh, very, very good. So that's correct. So 0.0.0.0/0 represents all IPv4 addresses. So what that means is, in a public point of view, it means all addresses that are in the world of the internet applies to this rule, to rule 100. So what this rule is really saying in terms of our network ACL is it's really saying all kinds of traffic from anywhere on the internet is allowed in. Outbound rules says all kinds of traffic heading to anywhere is also allowed out. And I think the T is whether or not 0.0.0.0 only represents things from outside the VPC. Is that correct? I think the interesting thing to think about is technically it should also include all traffic that is inbound as well, because 0.0.0/0 is definitely going to still let in any kind of traffic that's somewhere else in the VPC, but maybe a different subnet, like a different neighborhood that's trying to access the resources in your subnet as well. So I thought I'd add that little note as well. Okay, so once we've created our network ACL, is that our job done here? Almost. We're almost ready to get to step 2. I think the one thing that's left to do is to edit our subnet associations and make sure that our public subnet is actually associated with this ACL. Because wouldn't it be so funny if you do all of the hard work of setting up a network ACL, you're kind of like rallying this entire group of community watchmen or border patrol. You kind of just rally it up and you're like, okay, team, I've set up some inbound rules for us. I set up some outbound rules for us. Off you go. And they're like, yay, off we go. Where do we go? When you don't associate a subnet, you're basically setting up resources, but not letting you know which part of your VPC it is relevant to. So in this case, our poor group of community watchmen are going to be so confused, not knowing which subnet they're actually protecting. So let's tell them which subnet they're protecting. So we're going to edit subnet associations and click on the tick that's next to public 1, and then click on Save Changes. And basically what we've just done is basically tell the community watchman that we set up, hey, you're going to be protecting my public 1 subnet. So now we finally have the network ACL that's sitting outside of our public subnet. So this thing is finally created now, and just by creating the subnet associations, we're pretty much filling in that arrow here. Because if we don't have that arrow, we pretty much have the network ACL, we have our subnet, but they're not even connected at all. So I think that's one underrated thing about these diagrams, is you really have to be focused on not just creating the resources themselves, but also figuring out how you're going to connect them with the arrows. Yeah, I think that's one thing that's slightly underrated about these diagrams, actually. We need to talk about the arrows a bit more because the connections are just as important as setting up the resource. Cool. Well done. That was a huge step one, but it means that what we've done now is setting up a very fantastic foundation for the rest of this project today. So what we're going to do now is we're going to set up a private subnet. We've learned about subnets. We've created the public subnet that's connected to the internet. And now we're going to create the private subnet for the resources that we want to keep private. Like we've mentioned before, it is very common for engineers to set up an EC2 instance, hosting a web app in the public subnet, and hosting in the public subnet is so important. Why? Because it is only accessible from people in the internet if your subnet is public. But let's say we have a whole database of customers and their login details. Do we want that to be in a public subnet, guys? Is that going to be what we want for the best security practice? Probably not, everyone. It is probably important that any database of sensitive information, or in other cases, for example, you have files that you want to keep secure and not accessible from the internet, that stuff should be kept in the private subnet. So let's set up your very first private subnet and learn its differences along the way. So now that we have done all of the work for a public subnet, we are actually just going to go back and revisit a lot of these elements in a VPC and pretty much create the private subnet version of it. So first things first, we're going to create a subnet. We have public one here. It's looking very good. And we're going to create a new subnet that's going to sit next to it. That VPC that it belongs to, should it still be in the same city? Yes, it should. So you can now think of this public subnet to be another neighborhood, inside your VPC. It absolutely still sits inside the same city, but let's just say that this neighborhood isn't a public area anymore. If you think of your public subnet kind of like a public mall, a library, a park, these are kind of neighborhoods in the city that are very much accessible to anyone that visits. The private subnet is kind of like your own home, or this is going to be like a private area that you wouldn't really say is open to anyone that just visits. I always like to think of like public subnets as touristy areas with a lot of tourists, like people from the internet coming and visiting. And then the private subnet is kind of like the private gated neighborhoods that you don't really like, that a tourist can't really just wander in and be like, ooh, like, hi. Private subnets are absolutely just kind of closed off from people trying to access it from the internet. By default, that's what it does. And now that we've created the subnet, now that we have associated it with the same city, our network VPC, and we're going to give it a subnet name. So the name is going to be very simple, network private subnet. I don't think you can get any more self-explanatory than that. If you have a suggestion, chuck it in the chat. I'd love to see it. And the availability zone, this is going to be important. The availability zone that we want to pick is not the first one, but the second one. Click the second one on that list. And if you're wondering, am I going to do something wrong if I select the first one? No, you can absolutely create a subnet that's in the very first availability zone too. But we're going to create a second one because later on in this project series, that's going to come into use very, very soon. Maybe not so much in this project specifically, but in the future ones, absolutely. So if you're wondering what is an availability zone, again, by the way, an availability zone is pretty much a cluster of data centers that live in the region that you're working in. We're now zooming out from this entire like VPC and city analogy. Let's just zoom out and look at the entire region as a whole again. In the huge region that you're a part of, where are the data centers, or where are the data rooms that are really powering all of the resources that you're creating in the cloud? All of those data centers are in clusters throughout the region. And each cluster is an availability zone. So in my region, Oregon, there are 4 clusters of data centers that are just scattered around the Oregon region and are pretty much the computing power that is like creating all of the resources that I'm setting up in the cloud in this region. And I think most regions have at least 2 availability zones. Only smaller, newer regions would only have 1 availability zone or none at all. In our case, we're gonna select the second availability zone in the list, and what that means is this VPC, this subnet is still gonna belong on the same VPC, but then the resources that get created in that subnet, they're gonna get created in a separate cluster of data centers from the first cluster in the entire region that you're operating in. So now that we've selected the second availability zone, we're going to have a look at this very, very important field, the IPv4 subnet CIDR block. We've done this before, haven't we? When we created the public subnet, we have already defined an IPv4 CIDR block here. And what that CIDR block was 10.0.0.0/24. This was the CIDR block that we assigned our public subnet. What do you think is going to happen if we try to assign the exact same CIDR block to the private subnet? Can two subnets have the exact same CIDR block? Is the question that we're asking. So, as you might recall, CIDR blocks are kind of like groups of addresses, like a chunk of addresses that now belong to the subnet that you assign it to. So can two neighborhoods in a city have the exact same set of addresses and postcodes? Let's find out. So we're going to scroll down now that we have selected our CIDR block. And we're going to click on Create Subnet at the bottom here. Oof! Did you see that error? That's an error over here. We can't create the subnet because CIDR address, the CIDR address that we've associated for our IPv4 subnet overlaps with an existing subnet CIDR. Isn't that cool? So this is literally AWS saying like, hold on a second, I can't let you create this new neighborhood that you're trying to create. I can't let you do that because the addresses you're about to assign the subnet is exactly the same as the addresses you've already given away to another subnet. It's a very, very important piece of information if you are studying for the cloud practitioner exam, for example, to know that in the world of networking or in the world of your own VPC, CIDR blocks or IP addresses can't overlap between subnets. You can't overlap. The addresses need to be completely unique, or really they need to be completely separated or independent from one another. So what that means for us is we are going to need to give our private subnet a completely different CIDR block. So to do that, we're just going to do one small change. Do you see how it says 10.0.0.0/24? We're going to move that middle zero and make it 10.0.1.0/24. Let's click on Create Subnet again. And there we go, we can actually create the subnet now. So by just changing that little zero in the middle to a 1, we are effectively giving it an entirely different block of addresses. And that really just goes to show the flexibility of IP addresses and just that insane range that you can create just from those little 4 sets of digits. Because if I were to do 10.0.2.0/24, that's a whole different CIDR range again, and that gives me like another subnet that I could create. And you can go do that all the way until 255. So 10.0.255.0/24 absolutely could still be another CIDR block for another subnet. So wow, all the way from 0 all the way to 255. Like just think about the number of subnets you could be creating. And the range actually is so much bigger than that as well. But yeah, that was really cool. We've just created a private subnet. Let's have a quick chat with the chat as well. Wow, this is so cool. Uday says, hi Natasha, one of the best channels recommended by YouTube. Uday, stop it. That's too flattering. Oh my goodness, thank you so much. King of Zamunda says the visuals make the concept sink in. Very, very glad to hear that. More reasons I'll be here for other sessions. Yay, super cool. Hope to see you in another session too, Zamunda. And Unique says, I thought load balancers could forward traffic to web servers on private subnets. Yes, Unique, I love this so much. Unique, you've asked a very, very good question. Your question is actually a little bit advanced too. So for anyone that is new to the concept of load balancers, we will talk about that in a future project. And load balancers are basically kind of like, again, like a traffic controller, but they help with managing a huge inflow of traffic and divide that across different EC2 instances in your VPC. And yes, they can forward traffic onto private subnets, but that private subnet needs to be configured and open to the internet. So there is a way that you can make private subnets open to the internet, but it is a very, very specific way using a tool called a NAT gateway, an NAT gateway. And NAT gateways unfortunately cost money for us to use in an AWS account, which is why we're going to leave it off of our project series. But absolutely, if you look into NAT gateways, you'll be able to connect the dots between how a private subnet is considered private and away from the internet, but you could still have a NAT gateway as well. I'd recommend looking into that unique. Supriya Chatterjee says, one question regarding the CIDR block assign. How are we judging what CIDR block needs to be or should be assigned for a specific zone or subnet? Kind of any formula or rule to check and calculate that? Ooh, Denzel also says that is a good question, Supriya. I agree. Supriya, I am loving that question too. How I'm reading your question is, how are we going to figure out what CIDR block to assign to a new subnet? Honestly, this is something that is so flexible and up to you, in my opinion. But a really, really standard way of doing this is to first, if you're thinking about it in a /24 range, so you know how we had 10.0.0.0/24. When we're talking about things in the /24 range, we would only want to change the numbers here to start with. So we would only want to change this to 1, and then 2, 3, 4, 5, and go up from there. The reason why we wouldn't touch this final number here is because when we define a range that has /24, we're pretty much saying 10.0.1.0, for example, is basically saying the entire range of IP addresses from 10.0.1.0 all the way to 10.0.1.255. That's exactly what this CIDR block is really saying. So you can imagine how if you are affixing a number here, if you're giving it a number here, it can make your range super confusing. The range of digits starts going across the second set here. So you will want this number to stay as 0 at the end over here. And then the middle number here can become a bit more flexible and go all the way from 1 to 255. So once you max out your subnets and you get to 10.0.255.0/24, then you will start to move this needle. You move this needle and make it 10.1.0.0/24, and then you'll move that needle all the way until this gets to 255 again. And when it gets to 255, you've maxed out all of the subnets. You've maxed out this entire range. Then you move this up into 10.2, like this, 10.2.255.0/24. So just keeps going on and on and on and on until you are getting to a really, really high number. But trust me when I say this, oh my goodness, an entire range of IP addresses, huge. It is just so huge. It is very unlikely that you get to max it out. And it's why this IPv4 addressing this way of assigning IP addresses has lasted us such a long time. Because if you think about it, public IPv4 addresses 0.0.0.0/0, the set of all IP addresses in the world, we're supposed to be able to assign this to every single server, every single device in the entire world. How is that even possible? This could only be possible if this range is big enough to kind of serve that many devices and that many servers. The hint is, though, actually, we have actually pretty much run out of IPv4 addresses. We're pretty much like close to capacity with IPv4 addresses in the internet, in the world of the internet now, in the public space, which is why something called an IPv6 system has come out recently. And that is kind of like a new addressing system with an even larger range of IP addresses. But we're not going to play in that range today. For this series, we're going to play in the IPv4 space because it is still, at the end of the day, more common than using IPv6. Because we have been using IPv4 for just such a long time. I hope that explanation helps. Denzel says, ooh, in the chat. I hope that's interesting. Again, such a good question. So we have just created our private subnet, and it has its own set of IP addresses. And what that means is we can now take a screenshot and create and start writing a bit of documentation for what we've done so far. Cool. So our screenshot is actually supposed to be of the subnet settings panel, which I've clicked away from. So what we're going to do is I'm just going to redo that step, and everyone in this call together are going to pretend that I'm taking the screenshot like I'm seeing this for the very first time. We're just going to pretend I haven't actually created the subnet yet, and I'm just taking a screenshot like I'm seeing it for the first time. So the subnet name is going to be network private subnet. I'm redoing these steps purely for the sake of taking that screenshot and putting it in my documentation. Availability zone is the second one in the list. The IPv4 subnet CIDR block is going to be 10.0.1.0/24. Supriyo says, thanks, awesome explanation, concept is clear, thanks a lot. That makes me so happy to hear. Thank you so much. I'm so glad that it was clear. That's so cool. Actually, before back to what we were saying just now, Supriyo, about the subnet, like CIDR blocks and the ranges, you can absolutely have a range that is different in the slash. It can go from 32 to 24 to 16 to 8. The smaller the number, the bigger the range. And you can absolutely change the number after the slash depending on how big your VPC is in itself. Because if our VPC is as big as 10.0.0.0/8, that's a much bigger VPC, then the range for our subnets can actually go all the way up to 16 as well. Like this is a whole other this is a whole other game that we're going to play, like if we're going to get to this stage. But as you can see here in this this little helper here, it actually tells you how many IP addresses is in a range once you type it in. I should have mentioned this just now. I only just realized it as well. Look, if I type in 24 here, how many IP addresses get created? 256 IP addresses. Why? Because it goes from 10.0.1.0 all the way to 10.0.1.255. But if I were to change this range to 16, that's 26 to 16. How many IP addresses is that? 65,536 IP addresses. If I were to change that to 8, how many IP addresses? Look, you can't even see it, but it's, is it a 16 million? Or is that like 1.6 billion? Many, 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 many more IP addresses is the point. If I change that to 32, by the way, how many IP addresses is in this CIDR block? One. Just one. So 32 is pretty much the biggest number you can put behind a slash here. And yeah, as you change this number after the slash, you're pretty much changing the scope or how big or how small your subnet is going to be in terms of the number of IP addresses inside. But it's always standard to go in increments like this, to go from 8, 16, 24, 32. That is the standard. No one really plays at numbers outside of those, just for like consistency's sake. Okay, I hope that was very clear. And I've taken my screenshot, right? I think I've done that. So I've taken the screenshot, and we're going to head to our documentation template over here to write down our notes from that very first step. So I'm going to paste that screenshot. We have created a private subnet now. That screenshot looks quite good. I'm going to just double click on my image to enter into this view where I can edit my screenshot. So click. I'm in this view now where I can edit the screenshot itself. And all I've done is I've just dragged the photo down so that I can see my entire settings panel. Cool. Now that that's done, let's fill in some of the prompts for our documentation. And all right, create a private subnet. Create a private subnet has 3 prompts for us today. First things first, the difference between public and private subnets is that, what's the difference, team? Do you still remember? The difference is that public subnets are accessible by and can access the internet, while private subnets are completely isolated from the internet by default. Next, let's have a look at what's next. Having private subnets are useful because, why do private subnets exist? Having private subnets are very, very useful because keeping resources away from the internet is extremely important for the security of confidential resources. And I'm gonna just decrease the font size a little bit, bloop, 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 like this, so I can fit more text in my page. And the next prompt says, my private and public subnets cannot have the same. What can't your private and public subnets share? It can't have the same IPv4 CIDR block, i.e. the same range of IP addresses. The CIDR block for every subnet must be unique and cannot overlap with another subnet. I think that is the reflection of the prompts done for this step. Very, very happy with that. I hope you are too. So with that step done, I think we're now ready to move on to the next step. Before we do that, actually, I've just noticed that there's one more step for us to do in this section. Let us keep the naming of our subnets consistent. We have one name that says public 1. We have one name that says the network private subnet. So let's keep the naming convention very, very consistent by renaming public 1. Let's click on the pencil icon next to it and change that name to network public subnet like this. Click save and you're done. Renamed just like that. Very beautiful. I think it looks very nice and consistent now. And we can now set up a private route table next. So a private route table, what does it do? I think a really, really good hint lies in the step-by-step guide and the diagram here. And given that King of Zamunda also said that the diagrams really help with the concept sinking in, let's take an extra minute to talk about this diagram. So we have our public route table. Let's look at what we've done already. And our public route table is kind of like that friend or that connector between the internet gateway, which is again that ship or that plane that can leave your VPC and take data out of your VPC and into the world of the internet, or the other way around. And it also connects it with your public subnet itself. But really what this public route table does is it gives directions for resources wanting to get to another destination. So a public route table is that GPS that can basically say, you want to get to the internet? Here's how you get to the internet. Oh, you want to get to another resource inside this VPC? Here's how. I'll show you how. So this route table is really, really important to make sure that resources in your VPC and outside of a VPC can navigate and make their way around your network easily. So notice how we are now creating a private route table. And notice how it doesn't have that arrow, that connection to the internet gateway. Ooh, interesting, isn't it? So why do we not have that connection to the internet gateway? It's because this subnet is going to be private. It's going to be isolated from the internet. We don't want people from the internet to be able to access our private subnet. So should we give our resources directions to the internet, directions to the plane that can, take them off and leave the city? No, No, we're not going to do that. We're going to make sure that all of the resources in our subnet only know how to get to other resources in our VPC in general. So that means resources in a private subnet, absolutely by default, usually can still access and visit other resources in your VPC that sit in another subnet. Like that's called internal communication. But in terms of external communication with the internet, yeah, we're cutting all of that off, guys, with the private route table. And that's the reason why we need to create a new route table instead of just use the existing one. If we want to associate our private subnet with this public route table that we've created, that means that people from the internet can now access our private subnet. Is it a private subnet anymore? Probably not. So we're going to just make sure that the private subnet has a private route table associated with it. So that brings us to what this step 3 is all about. So let us click on route tables in the very left-hand navigation bar here. And let us create a new route table again. So click on create route table. And under name, we're going to call it the network private route table. Like this. And under VPC, make sure you're selecting your network VPC, not the default VPC, the other VPC option. We don't want this, we want network VPC. So once we've done that, we can create the route table. Select create route table. And are we done? Are we done? We've created the route table. Is that all done? No, it's not, guys. So once we've created the route table, don't forget the arrows are just as important as the resources themselves. What we've just created just now is the resource private route table. Don't forget the arrow. We need to make sure we make that connection, everyone. So let us associate our private route table with a subnet. So click on subnet associations and click on edit subnet associations. And then we're going to click on private subnet. Click on that and save your association. Ta-da! All done. So what that is doing now is we are pretty much making sure that all of the resources in our private subnet have this GPS, the private route table, to help them find their way around our VPC. And what's on the GPS? The GPS automatically already gives them the route to every other resource that's in the entire VPC. So they already can find their way around the entire VPC, but can they find their way to any IP address outside of this range? No, they can't. So there's no way for them to find the internet gateway, no way for traffic to leave the internet, leave the VPC for the internet. So I hope that helps. All right, so that is the route table all done. And this isn't mentioned in the step-by-step guide, but this is something that I noticed when I was writing this project, and I thought it could be a fun thing to mention. So let us also this is an extra little bit. We don't need to do this, but I just thought it's quite interesting. So once you're in the explicit associations kind of tab, remember how when you click on edit subnet associations, actually no, before we do that, I'm just going to mention, here are the explicit subnet associations for all of the route tables in your account. Oh, Joe says, I have people to pick up from the airport. Love the vibes as always. Thank you, Joe. Hope you have a great time picking up your your friends, family from the airport. See you in the next live. Thank you so much for being here. And when that message makes my day, by the way, Joe. It's always so fun to see your updates. So in your route tables tab, in your route tables page, do you see how there's this column that shows you your subnet associations? So this is telling us right now that network route table has the network public subnet associated with it. That's what we want. And then the private route table, that's the one without a link to the internet gateway, has the private subnet associated with it. So what if we would edit our subnet associations and click on the public subnet? So now our private route table has both the public and the private subnet associated with it. If we click on save associations, what's going to happen? Whoa, did you see that? Now our private route table has 2 subnets associated with it. How many subnets are associated with our original route table that has the link to the internet gateway? None. Do you see how the moment we associate a new subnet to our private route table, the other route table now has no subnets associated with it? And the real, I think, important takeaway of that's also very relevant to like the cloud practitioner cert is the fact that subnets can only be associated with one route table. That's kind of been my big learning around it. We're going to make sure that our public route table still has that route to the internet gateway though. So let's bring it back. Let's click on edit subnet associations in your original route table. And let's just make sure your public subnet is back to associating with that one. But that was very cool, right? If you were to associate your public subnet with this other route table as well, your original network route table will have no associations at all. So pretty cool learning to have. And let's also retitle this so that our naming conventions are again consistent. Let's call this one network public route table, like this. And let us click save so that our names are very consistent. Looking good, team. Now that that's done, let's take a screenshot of our new route table. So click on private route table here. Oops. And click on routes. So now that we have routes, take a screenshot of your routes. There we go, voila. Okay, so I'm just gonna quickly check in with the chat as well. Ziblim says, hello everyone, just dropped in. Hi Ziblim. So what is the difference between NAT gateway and internet gateway? Oh, very good question. So Ziblim, we've actually just touched on NAT gateway slightly earlier in this chat, which is why I find it like such good timing. So what a NAT gateway does, it is called a network address translation. And what it does really at its core is help your private subnet also get access to the internet in a very secure way. We don't get to touch on NAT gateways in this project series because they cost money to use, but absolutely they are also quite relevant if you're studying AWS and from a theoretical point of view. The difference between NAT gateways and internet gateways is you would use internet gateways for public subnets, and typically you use NAT gateways for private subnets. Natasha, the simple change you did on the route tables would make the private route table have access to the internet, no? Ooh, let's have a chat about this. No, not exactly actually, King of Zamunda. So what I did just now was I associated the public subnet with the private route table, and what that would have done is my public subnet would no longer have access to the internet gateway. It's kind of like giving that private route table, that private GPS to our public subnet as well. And now our public subnet will go, I want to get to the internet, how do I get there? They will look at the public route table, which only has one route to it, and it's going to get lost. Your resources in your public subnet would also be like, I don't know how to get to the internet gateway. And they wouldn't have a way to pretty much leave the VPC and enter the internet. So the effect of associating my public subnet with the private route table is actually removing access to the internet for resources in my public subnet instead of the other way around. So I hope that helps. Let me know. Very cool. I have taken that screenshot. So I am going to just switch tabs over into my documentation template again and let us paste that screenshot in here. King of Zamunda says, oh, it's the other way around. I understand now. Hey, I'm glad the explanation helps. So sometimes when you paste in a screenshot, you're going to notice that it doesn't give you everything that you want to show. The frames sometimes don't have the perfect dimensions to your screenshot. And if that ever happens, adjust it. Know that this frame can be moved around. And what you can do is you can select one of the edges and just pull it, pull it around. It's very flexible. Don't be afraid of breaking it. Pull it around so that it finally fits the dimensions that you have. So I'm going to make it look like this. I quite like this. I think that looks pretty nice. And then I'm going to fill in the prompts. So let's fill this in together. A dedicated route table. Interesting. We have 4 prompts to fill in. Route tables are What do route tables do? By default, my private subnet is associated with, ooh, okay, interesting. To make my private subnet private, I had to set up a new route table because, good question. My private route table only has one inbound and one outbound rule that allows, what does it do? This is very cool. So have a look at these prompts and have a quick think of how you would respond to each of these questions. I realize that a lot of the time we dive into answering these questions straight away, but actually let's take 30 seconds, just have a look at the prompts, have a look at how you would answer these questions yourself. It's a nice reflection time. I hope I don't choke on this water. I was just trying to drink water and I ended up choking on it. That was so funny. I can't believe I did that in a live as well, of all places. So I'm a little bit embarrassed now. Oh my gosh. I was just trying to drink water. Oh my goodness. But we're live. We're back and we're going to answer these prompts. So route tables are like GPS devices that help resources in my subnet navigate and get to their destination, navigate my network, and get to their destination within my VPC or beyond. Cool. By default, my private subnet is associated with, oh, yes, this is one thing that we didn't get to say very, very clearly, but by default, if you don't create another route table, by default, your private subnet will be associated with the default route table, i.e. network route table, i.e. the route table, a route table that has access, that has a route to an internet gateway. To make my subnet private, I had to set up a new route table because my subnet can't have a route to an internet gateway. My private route table only has one inbound and one outbound rule that allows, what does it allow? We can always revisit your route table and look at the routes to understand what's happening here. So my private route table only has one inbound and one outbound rule that allows internal communication, i.e. with a destination of another resource within my VPC. So that's what your private route table does. All right, all done. I'm gonna again make my font slightly smaller so I can fit everything in here. And now that we're done with this set of prompts, I think we're ready to get to the next bit. Lilo says, I'm loving this live. Is that true? Ah, that makes me so excited. What? Lilo, you're such a vibe. Thank you so much. That's so cool. All right, step 4. Let's set up a private network ACL. Oh my goodness, you can't even see the photo. That's something I'm going to change right after this live. Let me write a quick note that I'm going to update this photo. Quick pause, team. I'm just going to write update photo on a little sticky note so I can update this photo right after this live and you can see this photo. And what is the private network ACL? I'm going to scroll up and find the equivalent photo above. So we're now done with the private route table. We've created it now, but right now we're going to set up the private network ACL. This private network ACL is going to be what lets in traffic and what lets out traffic for your private subnet. Now, we have already talked about the public network ACL, remember? And when we talked about the public network ACL, we said that they're kind of like the community watchmen that kind of sit at the border of your subnet and protect what kinds of traffic can go into your public subnet and what traffic can leave your public subnet. Your private network ACL does the exact same thing, but for the private subnet. So you can think of like another set of community watchmen, another group of community watchmen, but this group is now protecting another neighborhood, another suburb. So they can have completely different rules, and we're going to see that in action with this step right now with the network ACLs. So I'm going to scroll back down. Perfect. And we're going to start by just clicking on network ACLs in the left-hand navigation bar here. Click there. And now that we're in network ACLs, we're just going to create a new one. This new one is going to be called, oh, actually, sorry. I think there's another important thing I'd like to mention before we create the new network ACLs. The important thing I want to mention is, before we create that new network ACL, look at what's on the network ACLs page. Just have a look at this. Do you see anything interesting here? I'm going to give us 10 seconds. So that was 10 seconds. What was interesting on this page is that if you look at associated with, do you see how your private subnet is already associated with a network ACL? You haven't even created a network ACL yet. Somehow, your private subnet is already associated with one. Hello? How is that possible? How you can investigate this is by clicking on the checkbox in the row that is associated with your private subnet, and look at the inbound rules and the outbound rules. Interesting. So what is happening here is, because your private subnet doesn't have its own network ACL yet, it is being associated with your VPC's default network ACL. So every VPC that gets created has a default network ACL that gets set up too. And that becomes kind of like that fallback network ACL that applies to all of the subnets inside if you don't associate a specific one. But do you see how this, although is a very, very good fallback measure to have, isn't going to be very, very helpful to us? We don't really want that default network ACL. Because what does that default network ACL do? It is allowing in all traffic. What? It is also allowing out all traffic. What? Do we want that for your private subnet? Is this good for your private subnet security? Probably not, actually. What is happening here is your AWS has pretty much like discharged this group of community watchmen to your private subnet by default. And it's told that group of community watchmen, just let in all kinds of traffic. And all kinds of traffic that wants to go out, yeah, just let it leave as well. You're pretty much giving your community watchmen like free reign to just let in everything and let out everything as well. Now that we already have a route table now that we already have this private route table that has not a single route to the internet gateway, you would assume this is okay, right? Yeah, it should be fine, because it's not like the traffic inside my network ACL can actually find their way to the internet. So it should be fine. And that's correct. You're right. Because our route table already doesn't have a route to the internet gateway, it means traffic by default can't even access the internet in the first place. So there's less of a need for a network ACL to be that strict from that point of view. But network ACL is here because of security, for security reasons. And it's security best when it's done proactively before anything happens, or best when it's done after something bad has already happened and something's been compromised and you're like, oh, I should have done that. Let me set up security. It's ideally done beforehand, proactively, before anything could happen. And we're kind of like setting things up to be extremely secure from the get-go by creating our own network ACL. Because what happens is of in more complex security breaches or like security events, what could happen is an attacker could actually attack your public subnet first and then engineer or manufacture some sort of traffic to make it look like a resource from your public subnet is trying to communicate with your private subnet. And if your private subnet is letting in all kinds of traffic, it's just going to be like, oh, we just have another piece of inbound traffic coming in from somewhere else in the VPC. Of course, I'm going to let it in. Just lets it in straight away. Or, now that a piece of data is already within the VPC, it can easily just go inside your private subnet. Since your private subnet has such open network ACL rules going on right now. So I hope that helps to communicate just that importance of having really good security practices for your network ACLs for a private subnet, even if you've already covered your bases with the route table. So what's going to happen is let's create the network ACL, make sure we're protecting our private network, private subnet, and let's give it a name. All right, in the chat, we have Abdul say, sorry, Nat, drink easily. I will, Abdul. Thank you so much. Wesley says, the live is quite informative and hands-on. Thank you so much, Wesley. That really makes our day to hear. It really does. Kumo says, hey, Natasha. Sorry for not being active in the group chat. I've been preparing for my cloud practitioner exam. I'm writing on Sunday. Kumo, all the best. VS Patlola says, what is the next project? Ooh, so many good things are coming up in this series. I'm so excited. So excited. What's next is there's going to be work on testing your VPC's connectivity. There's also going to be work on VPC peering. So how can you get two VPCs to talk to each other? That's very, very exciting. Nice. Wesley got the question right when he said subnets associated with the ACL. Thanks for picking up on that just now when we were just looking at the network ACLs page. And says all the best, Kumo. Yeah, we're wishing all the best to you, Kumo, for your CCP exam on, when was it? Sunday. Super soon. You're going to crush it. You're going to crush it, bro. All right. So for your network ACL, let's give it a name. Network Private NACL. If you're wondering what is NACL, it's basically Network ACL. Altogether, NACL. So you're going to see NACL come up quite a bit, actually. A lot of people abbreviate the whole term like that. Make sure you're selecting Network VPC as a VPC that your access controllers is going to be living in. And let's create it right away. So we've created the network ACL. And what's next is we're going to have a look at the inbound rules and the outbound rules. Make sure you're selecting private NACL. And what does it say under inbound rules? Can you see it? I'm going to zoom in so you can see it. Okay, so inbound rules, all traffic from all protocols, all port ranges, deny, don't let them in. What's happening with the outbound rules? All traffic of all protocols, all port ranges, deny, don't let any traffic out. Whoa, these are some insanely strict NACL rules, and we're going to keep it that way. We're just going to keep it that way. We're not going to edit it and let in any traffic yet because we haven't actually set up any resources in our private subnet yet. A great thing to set up for privacy reasons is to first figure out and deploy the resources that you want to put into your subnet, and then you work backwards and say, oh, based on what resources I've deployed into my subnet, I'm going to allow these rules in my network ACL so that the traffic that my resources need is allowed in, and the traffic that my resources want to give out is allowed out. So we're going to do that. We're going to actually edit our inbound rules and outbound rules in another part of this project series when we actually know what kind of traffic is going on with our private subnet. This is actually quite relevant to a very important cloud practitioner exam concept. which is called the principle of like least security. And this is going to be an important like concept that basically just says you will only give what absolutely needs to be given to all of the resources that need access to your resource. Because if you give away too much access, things like resources or people doing things that they're not allowed to do or don't have permission to do suddenly happens because you give away too much access. And I would say that this principle is absolutely relevant when it comes to like the bigger piece of how people manage IAM access and user access as well to your AWS account. An absolutely important security principle that applies to the applications you deploy, as well as the VPCs you set up, as well as like the users that get to use your AWS account. So that's a small little tangent there, but a very, very important principle to think about. So it's called the principle of least privilege. I realized I might have just said principle of least security just now. I misspoke. It was principle of least privilege. And subnet associations, let's click on that tab and let us edit the subnet associations and make sure that your private subnet is associated with this group of community watchmen, this network ACL. Save your changes and you're all done. So once you've saved your changes, you can see your private subnet is now associated with your private NACL. Perfect. That is exactly what we want. We don't want it to be associated with that top network ACL that lets in all traffic and lets out all traffic anymore. So now that that's done, you can also tidy up your network ACL's organization by renaming this into network public NACL. So you can do that here, network public NACL, and click save. Done. That was really awesome. So network ACLs done, route tables done, subnets done. Oh my goodness, look at you go. You have completed the resources or the components you need to set up a private subnet. But before we actually finish off, let us write the documentation for our network ACLs portion. So we're going to take a sneaky screenshot of the inbound rules. Oh, that's not the right one. We want to look at the private NACL, not the public one. So let's look at the inbound rules and let's take a screenshot of our inbound rules. And let us add that to our documentation and use the page that has 2 screenshot spaces inside and put that in inbound rules, deny all. I think that looks pretty good. I think that looks good enough, right? Does it look okay? I think that looks okay if I were to move my screenshot around and make it look like that. And then next, outbound rules. Let's take another screenshot and add that in. Beautiful work. Let's put that in here. Bloop, just like that. And you can absolutely edit the shape of your screenshot as well so that it perfectly matches the size of your screenshot. Okay, cool. So now that those screenshots are in, I'm going to write into the prompts. King of Zamundas is done. Ombachi effect. Ooh, what is Ombachi effect? I'm super curious now. Can someone let me know if you like? I'm so curious what is Ombachi effect. All right, network ACLs are, what do network ACLs do? Network ACLs are a security component that protects that controls traffic. Controls traffic. I'm going to be even more specific. That controls inbound and outbound traffic at the subnet level. By default, my private subnet is associated with the default network ACL that's set up for every VPC created in my AWS account. Setting up a route without an internet gateway would already prevent direct internet access to and from my subnet. That's completely true. However, it was still important to set up a dedicated network ACL for my private subnet because a network ACL becomes crucial in the event of security breaches where traffic that has compromised my public subnet can get access to my private subnet. If I have ACL network ACL rules that allow all inbound, outbound traffic. That's on period. Andre says least security or least privilege. Principle of least privilege is the answer. Sorry for misspeak. Sorry that I mentioned the wrong term just now. I think, yeah, I definitely mentioned principle of least security by mistake in my first go. But search up principle of least privilege. I think that's going to give you the information that you're looking for if you're thinking about the security principle. That's about giving people or giving users, giving resources the least amount of access that it needs to really like protect the security of your resources, like your VPC or your AWS account in general. Okay, next. My new network ACL has two simple rules. What are the inbound and outbound rules in your new network ACL? Deny all inbound and deny all outbound traffic. That's how simple it is. We're just denying all traffic until we figure out what kind of traffic we want to let in the future. So that was amazing work, everyone. You have successfully created your network ACL. You have successfully created your private network ACL and also all of the resources that you need to set up your private subnet. So a big congratulations to you. Very successful project. And let us wrap up for the day. You might be wondering, wait, what about security groups? Hello, like security groups, didn't we set that up for our public subnet? Yes, we did set up a security group for our public subnet. But remember how security groups are actually securing your resources at the subnet level? Let me go back up to the diagram so you can see. Do you see how security groups secure your resources at the instance level, the resource level? Because of that, you don't actually need to figure out the rules for your security group until you have a resource you want to protect. So what that means is we will be creating a security group for your private subnet, that's related to your private subnet later on in this project series. But your private subnet doesn't need to have a private security group to be considered a private subnet, if that makes sense. You can absolutely still have a private subnet created with just these key components that we've set up, and that is still considered a private subnet in a VPC. The security group becomes important once you actually have resources that's been deployed in your subnet. So that's why it becomes relevant later on in the next project when we're deploying EC2 instances in your subnets as well. Cool, I hope that makes sense. And with that done, I think we're now ready to wrap up the documentation. So when you're wrapping up your documentation, absolutely, I would recommend... Oh, Uliana says, good night, everyone. Good night, Uliana. I hope you've had a good day. You can finish the prompts in this first page or the second page. It says, what is Amazon VPC? Introduce it to your readers. How are you using it in today's project? How long did this project take you? And absolutely choose a screenshot that you like from today's project and put that in the cover page as well. So when that's done, you're also ready to replace the image here with an image of yourself. So that image you can easily upload by clicking on Uploads in the right-hand side here. Click on Upload Files and then select an image of yourself. I think I have one that I might be able to use for today's project demo. Where did it go? Let's figure it out. Oh yeah, we had a team photo shoot recently. And there was a photo of myself from that team photo shoot that I can use. So let me select that. Do we like this? I'll just select this photo. And let's drag that photo into the page. So put it in. Voila! Your image looks good. Let's say your image is slightly short, and after you add it in, your image looks like this in your documentation. Like you're like, oh, my face looks kind of cut off. This can absolutely happen with some photos. What you have to do is just select the little frame surrounding your image and just drag it down like that. Just drag it down, and then your image can come looking fabulous in your documentation template. Awesome. So once that's done as well, you can also edit your documentation template by editing the fields your name and this LinkedIn link. So how you can do this very, very quickly is by clicking Command F, which opens up a search window. And then once you've did Command F, find your name like that. And then do you see that replace with field? Put in your name here. Replace all instances of the text your name with your name. So type in your name here, Natasha Ong, for example, and then click on replace all. Boom. Now automatically all of the fields that ask for your name is filled in with Natasha Ong or your name. And then same with the LinkedIn link. So find your LinkedIn link, all instances of this little placeholder, and replace it with your actual LinkedIn URL. Something like this, for example, and then click on replace all. Done. Now all placeholders that ask for your LinkedIn link automatically filled in. So satisfying, right? I love that little hack. Honestly, same thing with your profile. There's also a very fast way you can do this. Drag your photo into your placeholder again. Double click on the bubble so you can edit kind of like the ratio of that image in your bubble. I like to just drag it in so that you can really see your profile, because when someone's seeing your documentation, they're probably not gonna look at it. They're probably gonna read it like this, right? So you're gonna just want to make sure they can see your face. I feel like this is way too zoomed in though. I almost got creeped out by my own face. So I'm gonna just drag it around a little bit so it's not that zoomed in. I feel like this looks a bit better as my photo. And once that's done, okay, you can press Command C on your keyboard or Control C on your keyboard, and then head to the next page like this. Command V, okay? Stay with me. Command V, move that little screenshot so that it fits your bubble. Command C one more time, or press Control C one more time. Head to the next page, press paste. Boom! Suddenly it's in the perfect place. It's always in a perfect place now. Go to the next page. Command V. Go to the next page. Command V. Go to the next page. Okay, this next page, it doesn't apply anymore. But do you see how just automatically, once you copy it the second time, after that, when you paste it, it's always in the perfect place. So that's a really great way to just keep your documentation and your profile image consistent across your entire place. Awesome. So when that's done, and when you're done also typing, putting in all of your screenshots, you can download this PDF, download your work, as a PDF, and then share your work. first things first, share it with the community. It's been awesome seeing everyone share their projects. You know, whenever I have a question and we see the documentation posts. Handy tip, by the way, you can sift through all of the documentation posts and find them by clicking project documentation as kind of like a badge. And once you click on that, the post section is going to be focused on who has posted their documentation recently. It's a very, very filtered kind of feed for you now. Shout out to Denzel, by the way, 1 hour ago. You did the project while watching the live, like this exact live? No way. That's sick, Denzel. My goodness, it's like I'm seeing something happen live even while during the demo. That feels really meta. That's so cool. And when that's done, you can also share it on LinkedIn. So click on that little blue link here that helps you open a pre-filled post. So once you open that link in a new tab, you can see that this post has already been written out for you with an example copy. Have creative freedom with this. You can always edit whatever copy is in here, by the way. Always edit whatever hashtags, whatever you want to shout out. And then once you've edited your copy, click on the little X at the bottom, and then click on the plus icon, click on the little document icon, and then you can attach your PDF documentation. So let's just say that I have documentation I'd like to upload. Shout out to whose documentation is this? This is Fobara's documentation that I'm going to borrow for this demo. So let's just upload your documentation, your PDF that you've downloaded. Give it a title. So in this case, it's going to be creating a private subnet. And click done. That's like uploading your PDF to your post. And then you can click post, and then off you go. Your post is now in the world. And absolutely, by the way, we look at every single post that mentions Nixwork. So that's why when you're writing your post, this is what it looks like. When you're writing your post, you want to make sure that the thing that says @Nixwork, you highlight that, or you put an @ in front of it again, and then you click Nixwork in that drop down. Because once you click post, this is what's going to happen for the team. What we see as a team when we click on our notifications is we can see everyone that mentions Nixwork in their documentation like this. When you mention us, absolutely, we get to see it for sure, and we can go support, spread the love, comment, and say thank you so much from our end as well. It's been amazing. Just look at how much documentation has been posted lately. Let's all support each other, give each other lots of love. It is just so cool to see everyone create great things with AWS and learn along the way. So thank you so much for always posting your documentation, mentioning Nixwork. It is absolutely cool to see you giving back to the community in that way too. Awesome. So once that's done, let us delete the resources in our account, because your project's not done until those resources are deleted, team. Deleting is very, very easy with VPCs. All you have to do is click on your VPCs on the left-hand navigation bar, select Nixwork VPC, and then under the Actions drop-down, select Delete VPC. So let's delete it off of your account. Beautiful. And type in delete in the field at the bottom here, and click on the delete button. Whew. All deleted. That was fast, wasn't it? So deleting a VPC usually deletes all of the associated resources, but you can always double check this by just clicking on the other pages and refreshing the page. Do you remember what we said about how sometimes the page lags a little and it doesn't update in real time? This is going to happen for sure when you're checking your resources. Denzel says, hey, good night, everyone. Good night, Denzel. Hope you have a good night. Click on the refresh button in all of the pages, and you're going to see, you can just see all of the resources literally disappear in front of you, because your account is now, your page is now kind of like refreshing and showing you what's really in your account now. Look, network ACLs, all gone. Security groups, refresh that. Yep, the ones that we've created, all gone. So all of your resources are cleaned out, and that is networking project 3 done. Congratulations. Look at all of the things that you've created in this project alone. That is insane work. Good on you. You've done an amazing job and you've learned three very, very key things that we want to shout out as well. You've learned how to create the private subnet, that's that blue bubble at the top right hand corner. You've learned how to create a private route table. And this private route table doesn't have a route to an internet gateway, and that's what keeps your subnet private. And then you also create a private network ACL. Even though your private route table already doesn't have a route to the internet gateway, we still want to set up a private route table that's going to deny all inbound traffic and all outbound traffic by default. And this is such a great security practice to have. We only want to make sure that the traffic that's allowed into your private subnet is the traffic that we specifically trust. So great work setting up all three of these new elements in your VPC. I can't wait for you to try out the next few projects where you're really going to start deploying resources in the subnets, in your private subnet and your public subnet, and see whether or not you can set them up so that your subnets can still communicate with each other. You even get to test out whether the EC2 instances deployed in your public subnet can speak to the internet, connect to the internet, and get responses back to you as well. So lots of exciting things are coming in this series too. I can't wait to see you in the next one. All right, it's wild that all these learnings are packed in one single project. Great work. Give yourself a big pat on the back for all of your hard work today. We'll see you in the next project. A big shout out to everyone that's been so active in the chat, by the way. Denzel says, "Good night, everyone. I'm gonna be a DevOps engineer soon. Roar." The roar is always like, it just never gets old. It's so much fun to see. Thank you so much, Denzel. Thank you so much, Linda, for commenting and saying big ups, to Denzel. Absolutely. He's been an absolute star in this community. And thank you so much to everyone that's always been so kind and supportive in the chat, saying hi, giving responses to questions, talking to each other. It's what makes this community just such a warm and lovely place. So we're going to end the live today here. And we're going to see you in the next one. In the meantime, let's stay in touch in the community. I can't wait to see all of you posting your documentation for this project as well. I think it's going to be a lot of fun seeing what everyone gets up to. Awesome. That is today's live. It always makes me sad when it's time to end it because I'm like, oh, we can go on forever. But we're going to finish it now, okay? And I'm going to see you in the next one. All right. Bye-bye, everyone. See ya.